So ayun na nga, balik tayo sa discussion ko 'no. So, yung heat fusion ng water is, 143 BTU over found, okay? So more generally, to melt a mass M of material that has a heat fusion of LF requires a quantity of heat Q. So, dito papasok yung tinatawag na formula na Q is equal to mass and the heat fusion or LF. Ayan. This process is reversible, no? To freeze liquid water to ice at 0 degrees, we have to remove the heat. So the magnitude is the same. But in the case of Q is negative because heat is removed rather than added. To cover both possibilities and to include another kinds of phase changes, we can write Q is equal to positive or minus M and our heat of fusion. Ayan. Ito yung formula ng phase changes. Okay? Heat transfer and phase changes. Ayan. So, the plus or minus sign is used when the materials melt. So, the plus sign pala, yung plus sign nito, yung plus sign is ginagamit natin kapag magme-melt tayo ng isang material. So, yung minus naman or tinatawag na leaving heat is kapag magfi-freeze tayo. No? Magfi-freeze. So, the heat of fusion is different for different material and also varies somewhat with pressure. So, yung heat fusion daw is nakadepende kung ano material yung binibigyan natin ng init. The same time, nagbabago din siya kapag nagbabago yung pressure. For any given material at any given pressure, the freeze temperature is the same as melting temperature. So, at this unique temperature, the liquid and solid phases can coexist in a condition called phase equilibrium. So, we can go through with this whole story again for the boiling or evaporation. So, kapag nag-iinit tayo ng tubig at kapag nag evaporate na ito. So, a phase transition between liquid and gaseous phase. The corresponding heat per unit mass is called the heat of evaporation. Okay? So, papasok na tayo dito sa heat of vaporization. No? Or yung tinatawag natin na LB. At normal atmospheric pressure, the heat of evaporation of water, no? Kung pag-uusapan natin H2O, yung LB niya is equal to 2.256, no? Times 10 raised to 6. Ito ay naka-joule per kilogram. So, ito naman ay 539 cal per gram or equal ito sa 970 BTU ounce. So, yan. Ito naman yung LB. Kung kanina meron tayong LF, ito naman yung LB. So, that's it. So, sinasabi na it takes 2.256 times 10 raised to 6 joules to change ito 1 kilogram of liquid water at 100 degrees Celsius to 1 kilogram of water vapor at 100 degrees Celsius. Okay? By comparison, to reach the temperature of 1 kilogram from 0 degrees to 100 degrees. So, it requires, by comparison daw, para tumaas yung temperature of 1 kilogram of water from 0 degrees Celsius to 100 degrees Celsius, magre-require ito ng Q equals to M C M. Since yung temperature na, yung mass natin is 1 kilogram, okay? Tapos, yung C natin ng water is 4,190 joule kilogram Celsius. Multiply natin ang temperature changes na 100. So, ito ay tumataginting na 4.19 times 10 raised to 5 joules. So, para ma-compare natin. So, less than 1/5 as much heat is required for evaporation of 100 degree Celsius. No? Almost 1/5. This agrees with everyday kitchen experience. So, a pot of water may reach boiling temperature in a few minutes, but it takes longer time to completely evaporate at all the waterway. So, mapapansin natin to kapag nag-iinit tayo ng tubig, no? So, mas madaling makapagpakulo kaysa makapag-evaporate tayo ng water. So, like melting, boiling is reversible transition. When heat is removed from a gas at a boiling temperature, the gas return to the liquid phase. Ito yung tinatawag natin condenses. So, sa mga power plant, ito yung nilalagay natin ng malamig na part para bumalik sa liquid, yung gas. So, nangyayari din ito sa ating surrounding. Doon sa pag umakyat na yung evaporation sa ulap, nagko-condense na siya ulit. Okay? Temperature are always the same. At the same temperature, the liquid and gaseous phase can coexist in phase equilibrium. So, both heat of evaporation or LB and the boiling temperature of a material depend on pressure. So, water boils at lower temperature of about 95 degrees. So, and Denver than it's Pittsburgh because Denver is higher elevation and average atmospheric pressure is lower. So, pwede natin tong ikalin tulad sa Baguio. So, kapag nasa mataas tayong lugar, higher elevation like Baguio, mas madali lang makapakulo ng tubig. Okay? Kasi magkaiba yung pressure ng naka-sea level saka yung naka-elevate. So, the heat of evaporation is somewhat greater than its lower pressure. So, doon daw, kailangan mo lang ng, so may dot to dito, no? So, doon daw, kailangan mo lang daw ng 2.27 times 10 raised to 6 joules per kilogram. Okay? So, itong table na to is nagpapakita ng approximate specific heat and molar capacities. Okay? Ay, ito, kailangan natin. Yung itong table na to is yung nagpapakita ng heat of fusion and evaporation. No? So, pasok tayo ngayon sa isang example. So, ayan. So, a camper pours 0.3 kilogram of coffee initially in a pot at 70 degrees Celsius into 0.120 kilogram aluminum cup, okay, at 20 degrees Celsius. What is the equilibrium temperature? So, assume the coffee has the same specific heat as water and that no heat is exchanged within the surrounding. Okay? So, paano natin i-approach to? So, this is problem number 7. Okay? Problem number 7. Ayan. So, yung camper daw is naglagay ng coffee, no? Doon sa pot. Hindi, sa aluminum cup. Ito ay galing sa pot na merong temperature, initial temperature, no? T0. So, initial na 70 degrees Celsius. Tapos, meron tayong T na, hindi. Ito yung temperature ng coffee. Ito yung temperature ng aluminum na merong 20 degrees Celsius. Yan. So, hanapin natin what is the equilibrium temperature. So, our target variable is the common final temperature T, no? Ito yung hinahanap natin. So, of the cup of coffee. So, no phase changes occur. Okay? So, we need only the equation ng anong equation ba pwedeng gamitin natin dito? So, gagamitin natin equation. Okay na siguro to? Tama ba? Hindi. Ang gamitin nating equation dito is yung MCAT. No? MCAT. Gamitin natin equation dito is yung Q equals to M C change of temperature. So, ito yung gagamitan natin yung formula dyan. So, basahin ko ulit yung problem. Wait lang. So, dito, yung C natin is yung sa water. Change of temperature, meron na tayo, no? Okay. Wala. Wala pa ata tayo nito. Okay, yung mas meron tayo. So, T0 of coffee is 17, no? So, aluminum 20. So, kung pupunta kayo dito sa libro, yung table 17.3, makukuha na natin dyan yung C ng water. Itong C ng water na to, yung constant ng water, is 4190 joule kilogram. Ito ito ay para sa water. Tapos yung aluminum naman natin is 910 joule per kilogram. Ito naman ay para sa aluminum. Okay? So, yung heat na magigain ng coffee is negative. Tama? Kasi siya yung nagbibigay ng init, lalamig siya. Okay? So, ang mangyayari dito, ngayon is QC. QC ibig sabihin yun yung heat ng coffee equals to mass ng coffee. Tapos, C ng water. No? Tapos, change of temperature ng coffee. Okay? So, the heat naman is magiging ng aluminum cup. Okay? So, yung aluminum cup naman is magiging mass ng aluminum. Tapos, C ng aluminum. Change of temperature ng aluminum. So, we can set na yung Q ng coffee is equal to Q ng ating aluminum. Or mali. Teka. Mali yung analysis ko. Okay? Yung heat ng coffee plus heat ng aluminum, pwede nating equate ng 0. Dahil nga, equilibrium sila. No? Kasi, negative na heat ng coffee is equal to the positive heat ng aluminum. Okay? So, lalabas is ganito. Okay? So, next page tayo. Nakasya. So, ang mangyayari dito, no? Yung mass ng coffee, tapos C ng water, change of temperature ng copper is equal ngayon or plus mass ng aluminum cup, constant ng aluminum cup, and change of temperature ng aluminum cup is equal ngayon sa 0. Okay? Tapos, yung change of temperature ng coffee is equal to T minus the T initial ng coffee. So, ito yung final niya na hindi natin alam. So, ganun din, yung aluminum naman, yung change, ng aluminum is equal to T. Kasi parehas tong dalawang to. Minus the T initial ng aluminum. Okay? So, galing dito, pwede natin tong ipasok dito sa equation na to. Okay? So, pag ginagpasok natin yan, magiging Q C plus Q aluminum is equal to mass ng copper, constant ng water, plus yung T minus initial C. Okay? Plus yung mass ng aluminum, C ng aluminum or yung constant. Tapos, pasok natin yung T minus T initial ng aluminum. Equate natin to na 0. Tama? So, dito sa formulang to, pwede na tayong maglagay no given natin. Tapos, i-shift solve natin sa t. Okay? So, subukan natin. So, ano yung mass ng copper? Ay, hindi. Ng copper. Ng coffee? Yung mass ko ng coffee is 0.3 kilogram. No? Yung CW, ano yung kanina? 419 0 J per kilogram. Ngayon naman yung T is yung hinahanap minus the T nung T initial ng coffee. No? Which is 70 degrees. Or K. Yan. Plus natin to ngayon sa yung mass ng aluminum. Yung mass ng aluminum natin is 0.12 kilogram. So, meron tayong C ng aluminum na 9, 10 joule kilogram Kelvin. Tapos, hinahanap natin 70. So, yung sa ano naman is 20. Okay. Okay. So, okay. Equate natin to sa 0. So, ang lalabas dito yung T natin. So, using the calculator, hindi natin palabasin yan. 0.3 4190 alpha x minus 70 plus 0.120 multiply by 910 tapos alpha x minus 20 naman ngayon equal to sa 0. So, shift solve. Ang lalabas is 66.003 degrees Celsius. Yung answer natin dun sa problem number 7. Okay. Yan siya. So, okay na to. So, example number 8. Okay? So, sa example number 8 naman, a glass contains of 0.25 kilogram of omnicola. So, mostly water din to, no? Initially at 25 degrees. how much ice initially at negative 20 degrees must you use you add to obtain a final temperature of 0 with all the ice melted. Okay, so yun, so hanapin daw natin yung must you add to obtain. So ilan daw yung ice na kailangan nating i-add para makapag-produce tayo ng final temperature na 0 degrees Celsius with all the ice melted. So lahat ng yeloy natunaw. So neglect na lang daw natin yung heat capacity ng glass. Okay, paano natin i-approach? Pero mas maganda dito tayo sa bagong page. This is problem number 8. Oops. Ayan. Okay. So, the omnicola and ice exchange heat. So, nagkaroon ng exchange heat yung omnicola saka yung ice. So, the cola undergoes a temperature changes. Okay? The ice is undergo both temperature change and phase change from solid to liquid kasi nga natunaw siya. So, we use subscript C, no? Para dun sa cola. So, I naman para sa ice and W naman para sa water. So, yung C natin is yung sa cola. Yung I is ice. And W naman is water. Yung gagamitin natin subscript. Okay? So, ang target variable natin dito is mass of ice. No? Ang talagang hahanapin natin dito is MI. So, dito, gamitin natin yung formula na Q is equal to MCAT. Ayan. Itong formula to is gagamitin para doon sa amount of heat involved in cooling the drink. Okay? Gagamitin natin to para sa cooling. So, iba naman yung formula ang gagamitin natin para doon sa melting ng ice. Okay? Yung formula ang gagamitin natin sa melting of ice is yung Q plus or minus ml. Uy. Madaling tandaan yan ha. ml yan eh. Ayan. So, ito naman gagamitin natin para sa changes ng phase. Okay? So, makukuha natin yung expression for the heat required to melt the ice at 0 degrees. So, meron tayong initial heat ng ating cola, no? Ang initial heat natin dito is 25 degrees Celsius. So, ang initial heat naman ng ice natin is negative 20 degrees Celsius. So, galing dun sa table number 17.3, no? Yung sa water natin, constant ng water natin is 4190 joule kilogram. Okay. Yung C naman ng ice is 21 2100 joule kilogram. Okay. Okay. So, meron din tayong makukuhang LF, no? Na 3.34 yung kanina times 10 raised to 5 power joule kilogram. Okay. Ayan. So, una, gamitin natin itong formula lang to, no? At ko lang muna dito. Okay. So, magiging Q2 ng cola. Plus itong mass ng cola, C ng cola, or sabihin natin ito yung C ng water kasi almost water daw to. Okay. Tapos, syempre, change of temperature ng cola. This is negative. Okay? So, Q naman is nung ice is equal to mass nung ice, constant ng ice, and change of temperature ng ice. Okay? Which is positive naman ngayon. So, the mangyayari dito, meron pa tayong yung Q2. Yung Q2 natin is magiging M1 and L2 para dun sa phase change. Ay, hindi. Hindi to. Ay nating F. Ayan, para dun sa phase changes natin. So, pwede nating masabi dito na yung QC plus Q nung ice, yung heat ng ice, plus nung heat para matunaw yung yelo is equal to 0. Wait natin. So, ipapasok lang natin dito yung change of temperature, no? Yung change of temperature ng cola is mangyayari is T minus yung final temperature ng cola minus initial temperature ng cola. Ganun din yung nasa ice. Dahil equilibrium sila, yung T parehas. Yan, initial ng ice. Okay? So, isosolve natin yung M1. Nanganapin natin. Okay, ito. So, galing dyan, pwede nating sabihin na QC plus QI plus Q2 is equal ngayon sa MC tapos CW yung kanina. Change temperature nung cola. Kasi pasok ko sa parenthesis. This is for the cola. Plus M ng ice. Mas nung ice. Tapos yung constant ng ice natin. Change of temperature nung ice. Tapos para sa ice. Plus. Ngayon, M1 na hinahanap natin. Tapos natin yung LF, no? Yan. Ito naman yung para sa phase changes. Okay? Tapos pasok natin ngayon yung T. So, ito is magiging MC, CW. Papasok to, no? Ito ay magiging T minus the T initial nung cola plus MI, CI. Palitan natin to. T minus T initial nung ice na to plus MI LF. Ganda, no? Ayan. So, pwede natin ilagay dito yung mga given. Tapos, hanapin na natin C. So, dahil ito is naka-equal to 0, hanapin na natin si MI. No? So, dito, pwede natin itong rearrange, no? Pwede natin yung i-arrange para mapasok. Pwede natin i-rearrange para mahanap sa MI or gamitin natin ang calculator for shift solve. So, pag ni-rearrange natin yan, sa MI ngayon, no? Magkakaroon tayo ng formula of MI. So, magiging MI is equal to MC CW So, yan yung magagawa nating formula. Okay? So, pag pinasok natin dyan yung mga given, no, makukuha na natin sa MI. So, what is MC? Mas nung ating ice binigay sa problem. Mas nung ice natin is ano ba? Mas nung cola pala muna, no? Yung mas nung cola natin is 0.25 kilogram. Ngayon, CW natin, yung constant ng water. Ano yun? 4190 joule kilogram K. Tapos, initial ng cola. Initial temperature ng cola is 25 minus T. Yung T natin, so, dapat daw mag-0. Tama. Final temperature is 0. Tapos dito naman, sa baba is yung C ng ice natin. Ano yung constant ng ice? 2,100 joule kilogram K. So, change of temperature naman is from 0 to Yung initial ng ice natin is negative. So, magiging positive to. Kasi negative 20. So, positive 20. Yan. So, naging positive yan. So, para mas malinaw ganito. Minus 20 degrees Celsius. Magiging bracket to ngayon. Okay? So, plus yung LF natin. No? Yung LF natin is 3.34 times 10 raised to 5. So, joule, kilogram. So, using calculator, lalabas yan. So, 0.25 So, lalabas dito is naka-kilogram, no? Lalabas dito is almost, 0.7, 0.2. Sabihin natin yung MI dito is 0.07 kilogram. Equals to 70 grams yan. So, ito yung mass ng ating ice na hinahanap. Okay? Ito yung ating answer. That's for the problem number 8. So, pasok tayo nga dito sa mechanism of heat transfer. Okay, malapit na. So, if you hold, So, we have talked about the conductor and insulator, no, dun sa previous part natin. So, materials that permit or prevent heat between bodies. So, ito yung mga material na nagpipermit at nagpiprevent ng heat from between bodies. Now, let's look in more detail at rates of energy transfer. So, kunwari in the kitchen, use a metal or glass pot for a good heat transfer. For the stove, to whatever you're cooking. So, gumagamit tayo ng glass saka metal para dun sa pinaglulutuan natin kasi meron tong good heat transfer. Sa refrigerator naman natin, it's kailangan siyang insulated. So, meron siyang mga materials na ginagamit para makapag-prevent yung heat na pumasok sa loob and hindi mainitan yung pagkain na nasa loob ng refrigerator. So, paano natin i-describe yung difference ng two material? So, the three mechanism of heat transfer are conduction, no? Conduction, convection, and radiation. So, pinakaunang part natin is yung conduction na nag-o-occur within a body or between two bodies in contact. Okay? So, yung convection naman depends on motion of mass from one region of space to another. So, radiation naman is the heat transfer by electromagnetic radiation such as sunshine with no need of matter to present in space between bodies. So, focus muna tayo sa tinatawag na conduction. So, kapag hinawakan mo daw yung isang end ng copper rod and nilagay mo ito sa yung kabila naman is nilagay mo sa flame, the end you are holding gets hotter and hotter. So, umiinit daw ng umiinit yung hinahawakan mong parte ng copper rod. Even um, kahit hindi naman nakadirekta na hinahawakan mo yung apoy is mafe-feel mo yung init. Okay? So, heat reaches the color end by conduction through the material. Okay? So, on the atomic level, no, the atoms is the hotter region where have kinetic energy on the average than other color neighbors. So, sabi kasi dito, kapag, di ba meron tayong rod, itong end na to is hinawakan mo. Pangit talaga ng drawing ni sir. Kunwari, ganyan. Tapos, ito, is nilagay mo sa flame. Ngayon, dadaloy dito, yung init. So, paano yon? So, figure out natin siya dito sa loob ng copper rod. So, sa atomic level tayo. So, kunwari, ito yung nucleus natin. No? Ito yung electrons. So, kapag iniinit natin yan, so magkakaroon siya ng kinetic energy. Tapos, nagbibigay siya ngayon ng energy. Tapos, yung energy na yun is matatransfer to another copper atom. Yan. So, pag nag-transfer yung energy, is aabot dun sa kamay mo. Okay? So, the just tell their neighbors, giving them some of their energy. The neighbors just tell their neighbors, so, yun na nga, darating sa point na dadating sa nung dadating sa yung energy na yun. So, the atom themselves do not move from one region of material to another, but their energy does. So, most metals also use another, more effective mechanism to conduct heat with the metal. So, some electron can leave their parent atom and wander through the crystal lattice. So, the free electron can rapidly carry energy from the hotter to colder region of the material. So, metal are generally good conductor of heat. Okay? So, a metal rod at 20 degrees Celsius feel colder than a piece of wood. So, kadalasan natin yung mararanasan na yung 20 degrees na metal rod is mas malamig kaysa sa 20 degrees na piece of wood because the heat can flow more easily from your hand into the metal. So, the presence of free electron also cause the metal to be good electrical conductor. Okay? So, ibig sabihin, meron palang connection yung pagiging good conductor niya. So, of electricity. So, pagiging conductor niya ng heat. Okay? So, heat transfer occurs only between the regions that are at different temperatures, and the direction of heat flow is always from higher to lower temperature. Okay? So, makikita natin yan dito sa figure na to. Okay? Dito pinapakita yung cross-sectional area nung metal rod and yung length niya. So, at right end ng lower right end is a lower temperature and yung other naman is hot. So, yung heat daw is magpo-flow ng left to right. Okay? The sides of the bar are covered by ideal insulator o yung mga insulator na hindi nagpe-permit na magkaroon ng transfer of heat. Okay? So, when quantity of heat na dQ or derivative of heat or Q is transferred through the rod and dt, the rate of flow is dQ over dt. Okay? We can call this rate as heat current denoted by H, no? So dito siya. So nag-experiment, nag-experiment daw sila ngayon ng dalawang metal naman, no? So experiment showed that the heat current is proportional to the cross-sectional area of the rod. So makikita nyo yun dito. And the temperature difference is TH minus TC. And this is inversely proportional to the rod length. Okay? Introducing a proportionality constant K called the thermal conductivity of a material. So magkakaroon tayo ngayon ng formula na K A is multiplied by TH minus TC over L equals to H. So the quantity TH over TC over L is the temperature difference between unit length. Okay? It is called the magnitude of temperature gradient. The numerical value of K depends on the material of our material. So, tingnan natin, no? Ay, hindi ko na pinakita dito. So, tingnan nyo sa libro, table 7.5, 17.5. So, material with large K are good conductor of heat. So, material naman with small K are full conductor or insulator. So, itong equation na to also gives the heat current through a slab or any homogeneous body with uniform cross-section area perpendicular to the direction of flow ng heat. Okay? Yung L naman is yung length of the heat path. So, the unit of heat current H, yung unit daw nito, are units of energy per time or power. So, ang SI daw nito is, so, yung H daw, ang unit daw niyan kapag SI is 1 watt or 1 joules. Oops, mali. 1 joules per second. Okay? We can find the unit K by solving the equation. Pag sinolve daw natin yung equation kanina. So, the thermal conductivity of dead or not moving air is very small. Okay? So, a wool sweater keeps you warm because it traps air between the fiber. In fact, many insulating materials such as styrofoam and fiberglass are mostly dead air. So, yung mga dead air daw is yung mga hindi gumagalaw na hangin, no? So, ito daw ay merong very small na conductivity. Kaya yung sweater natin and styrofoam is nagpapainit sa atin. Okay? If the temperature varies in non-uniform way along the length of the conductor or conducting rod, we introduce a coordinate x along the length and generalize the temperature gradient to be d over t, derivative of t over derivative of x. The corresponding generalization is this formula. So h is equal to dq over dt, no? Pwede rin natin tong sabihin na k, negative k multiplied by the cross-sectional area, the derivative of t over the derivative of x. Okay? So the negative sign here show that the heat always flows in the direction of decreasing temperature. Okay? So for thermal insulation naman in buildings, yung mga engineer is ginagamit yung concept ng thermal resistant na tinatawag na R, denoted by R, no? The thermal resistant R of a slab or material with the cross-sectional area is defined so that the heat current H through the slab, ang mangyayari is H is equal to cross-sectional area multiplied by the quantity TH minus TC over R, resistant. So, yung TH and TC dito is that our temperature on the two sides of the slab. Okay? So, comparing this to equation na so, i-compare natin to dito sa equation na to, no? Kasi yung equation na yun is H is equal to Ka TH multiplied by the TH over TH minus TC over L. Kung i-compare din daw natin yan, ang lalabas dyan is R equals to L over K. Yan. So, yung L is the thickness of the slab, no? So, yung R natin, so ang unit ng R natin is 1 cube square meter multiplied by kilowatts over multiplied by K over W. Okay? And the units used for commercial insulating material sa US is H is expressed by BTU over H. Okay? So, 1 BTU over H is equal to 0.293 watts. So, tandaan nyo to. Ayan. So, pasok tayo sa example, no? Styrofoam cooler. Yung ginagamit ng mga natin, ng titinda ng paborito nating ice drop. Dahil sa ice drop na yun, sinipon tuloy ako. So, a styrofoam cooler has, so, meron siyang figure, no? Has a total wall area, including the lid, of 0.8 square meter and wall thickness of 2 centimeter. Tapos, nilagyan daw ng ice, water, and cans of omnicola. So, lahat daw is 0 degrees Celsius. What is the rate of heat flows in the cooler if the temperature of the outside wall is 30 degrees Celsius? So, how much ice melt in 3 hours? Okay? Paano natin to i-approach? So, this is problem number 9. Ayan. So, yung target natin dito are H, no? Yung H yung hinahanap natin dito. Tapos, yung mass ng ice na namimelt. So, dito, pwede natin gamitin yung equation na, aling equation? Pwede natin ditong gamitin yung formula na H equals to dq over dt is equal to yung constant na k, no? Tapos th minus tc over L. Ayan. So, pwede natin gamitin yung formula na yan para ma-determine yung H. Tapos, para ma-determine naman natin yung M, no? Para makuha natin yung M, ang gamit naman nating formula, ano kaya? Para yung kanina, no? Pwede natin gamitin yung formula kanina. Yung formula ng yung Q is equal to plus or minus ml. Naku, nakalimutan ko si ml. No? Q equals to plus or minus ml kasi nag-phase change siya. Parang ice na melt. Eh, huwag nyo kakalimutan yan. Okay. So, balik tayo dun sa problem. So, we will assume that the flow heat is the same as it would be through a flat styrofoam slab. Okay? So, meron daw styrofoam na meron thickness na 0.8 meters. Hindi. May area pala to. Ng 0.8 square meter. Teka, para mas malinaw. Yung area, 0.8 square meter. So, yung thickness natin is 2, no? cm. So, pwede ko na itong i-convert ng meter para pareha sila. 0.02 meter. So, yung K naman is pwede nating makuha doon sa table 17.5. So, sa libro nyo. So, dito muna tayo, no? H is equal to KA. TH over TC over L. So, galing dun sa libro, yung K natin is nakuha natin na 0.027 watts meter Kelvin. Multiply natin ang area natin na 0.8 meter square meter. Yan. No? Tapos yung 30 degrees Celsius. Tapos yung TC natin is 0 degrees Celsius. Ito yung outside heat, no? So, ito yung heat sa loob. Tapos meron tayong length or thickness, no? L or thickness na 0.2 meters. So dito, makukuha natin ngayon yung H. So using our calculator, no? 0.027 times 0.8 times 30 minus 0.02. Lalabas ngayon is 32.4. Ayan, degrees Celsius. So, hindi to degrees Celsius, no? Bakit degrees Celsius? Ito ay watts. Oo, watts yan. Kasi, makakancel to. Galing dito sa dalawa. Yung C is yung K din. Kakancel. So, what's yung matitira? Okay? So, ito ngayon yung hinahanap natin na H. So, pwede rin natin itong sabihin na 32.4. Ano ba yan? Bakit napipindot? Joules per second. So, parehas lang yan. Okay? So, doon naman tayo sa M. Sa M naman, ang gagamitin nating formula is yung Q. Tapos, yung paborito nating laro. Okay? So, dito, the total heat flow is Q equals to HT. Tapos, yung T natin is 3 hours. No? Yung Q kasi natin dito is pwede nating sabihin yung HT to. Tapos, yung time natin is 3 hours. 3 oras. Natin itong i-convert ng second, no? 1,800 second. So, doon sa table 17.4, pwede nating makuha yung LF, no? Yung LF ng ice or ice na 3.34 times 10 raised to the 5th power. This is joules kilogram. No? So, galing dito sa formulang to, na magiging M equals to Q over LF or L. Ayan. Multiply pala to by time. Yung H. Yung H natin is 30 no? So, galing dito, yung M natin is equal to yung HT. 32.4 joules per second. Multiply by 10,800 second. All over, the LF ng ice is 3.34 times 10 raised to 5th power na naka-joule kilogram. So, yung joule natin, matitira is kilogram, no? Yung seconds, makakancel din. Matitira is kilogram. So, calculator na lang yan. 3 point, hindi. 32.4 times 110,800 over 3.4, 3.34 times 10 raised to 5. So, dito lalabas is 1.0 or approximately 1 kilogram. Ito yung mass nung na-melt na ice. Okay? Yan. Is that for number 9? Problem number 9. Okay. So, example number 10 tayo. So, a steel bar of 10 centimeter long is welded end to a copper bar of 20 centimeter long. Each bar has a square cross-sectional area of 2 centimeter on a side. So, cross-section lang pala. 2 centimeter on a side. The free end of the steel bar is kept at 100 degrees Celsius by placing it in a contact with steam. And the free end of the copper bar is kept at 0 degrees Celsius by placing it in a contact with ice. Both bars are perfectly insulated on their sides. Find the steady state temperature at the junction of the two bars and the total rate of heat flows through the bars. Okay? So, dito maganda, i-sketch natin. Okay? So, na nga yan. Problem number 9. Number 10. Is problem number 10. So, sketch muna natin. Hindi ako magaling sa sketch, pero subukan. So, meron daw lower end. Nandito yung rod natin. Isa. Sino to? Si steel. So, si steel daw is nakakonect sa wall na merong TH na merong 100 degrees Celsius na steam. No? Ngayon, baguhin natin yung kulay para kay copper. So, ito naman ngayon si copper. Ayan. Nakakonect din siya sa isang wall. So, yung wall naman ni copper is yung color side na 0 degrees Celsius. Okay? So, dito, this is 10 centimeter, no? This is 10 centimeter. Yung copper naman is 20 centimeter. So, same lang daw yung ano nila na 2 centimeter cross section. Ayan. So, bali, ito yung situation natin, no? So, the heat currents and in these end-to-end bars must be the same. So, we have given hot and cold, no? Pinakita na yung TH is 100, tapos yung TC natin is 0. So, gagamit tayo dito ng subscript na S para sa steel. And C naman para sa ating copper. CU. CU ang gamitin natin para mas maganda. Para sa copper natin. So, meron tayong equation, no, na yung H is equal to K A TH over TC over L. So, pwede natin siyang i-rewrite, no? Pwede natin siyang i-rewrite na HS equals to KS. Tama? Oo, KS. Tapos A, TH natin, minus T over LS. Is equal naman to ngayon sa yung sa copper natin. Okay, ang copper. So, yung area is parehas lang, no? T minus TC over LCU. Ang LS natin dito steel. So, dito, pwede natin ilabas yung common na T by dividing both side by T. So, ang mangyayari, T is equal ngayon sa constant ng steel over LS. Mamumultiply ito ng TH plus K naman ngayon ng copper over L ng copper. Mamultiply naman to ng TC or temperature ng copper over KS over LS plus KCU over LCU ng copper natin. Ayan. So, isa-substitute lang natin dito yung LS saka LCU, no? Tapos yung TH and TC naman is binigay na dito. Yung KS and KU naman, makukuha natin dun sa table, 17.5. Okay? So, pag ginawa natin to, magiging, yung KS natin is KS steel. Puntahan ko, ako na lang yung pupunta dun sa table, 17.5. Pero makikita nyo yun dun sa libro nyo. Okay? Yung KS natin ng steel is 50.2, no? Watt meter Kelvin over yung LS natin. Yung L naman natin yung LS naman natin is yung length, no? Is 10 centimeter. Or sabihin natin, yung convert na natin to ng meter. So, 10 over 100. Magiging meter to. Yung TH natin, outside is 100 degrees Celsius. Yan. Plus, yung K natin ng copper, dun sa table, copper is 385. watt meter Kelvin. Okay? Over yung length natin, no? Na 20 centimeter. Magiging 20 over 100. Para maging meters. Okay? So, dito, magmumultiply pa tayo ng TC na 0. Ibig sabihin, mag-0 to. Tama? Over yung KS natin dito is 50.2 watt meter Kelvin over LS. Plus 385 ayan. So, pag kinalculate natin yan, hindi ko nakakalculator rin ha, lalabas dyan dapat is 20 degrees Celsius. Okay? So, yun. Hindi pa yun yung final answer natin. We can find the total heat current by substituting the T into either the expression of Hs or one of the H copper. So, kunwari, dun tayo sa Hs, no? Yung Hs natin is magiging formulang to. Papasok dito yung 50.2 watt meter Kelvin. 20.7 pala to, no? Tapos yung area niya, 0.20 square. So, multiply natin to ng 100 degrees Celsius minus yung 20.7 natin over 0.1 centimeter. So, HS dito is 15.9 watts. Ito yung answer natin. Okay. Okay. Balik tayo dito. So, punta naman tayo sa tinatawag na convection. So, convection naman is the transfer of heat by mass motion of a fluid from one region to space in another. Yun naman si convection. So, familiar example nito is yung tinatawag na hot air and hot water home heating system. Okay? So, if the fluid is circulated by a blower or pump, the process is called forced convection. Yun. So, if the flow is caused by difference in density due to thermal expansion, such as hot air rising, so the process called natural convection or free convection. So, ito din yung makikita nyo dito sa figure na to. Okay? So, the free convection is in an atmosphere plays a dominant role in determining the daily weather. And the convection in the ocean is the important global heat transfer mechanism. So, on a smaller scale, soaring hawks and glider pilots make use of their thermal updrafts from warm earth. Sa the most important mechanism of heat transfer within the human body. So, need to maintain nearly constant temperature in various environment. So, is first convection of blood with the heart serving as the pump. No? So, convecting heat transfer is very complex process. And there is no simple equation to describe it. So, here are a few experimental facts. So, number one, the heat current due to convection is directly proportional to the surface area. So, this is the reason for the large surface area of radiators and cooling fins. No? So, the viscosity of fluid slows natural convection near a stationary surface, giving a surface film on that vertical surface typically has about the same insulating values as 1.3 centimeter of plywood na merong R value na 0.7. So, first convection decreases the thickness of this film, increasing the rate of heat transfer. This is the reason for the wind chill factor. You get the cold faster in a cold wind and than in still air with the same temperature. So, number three naman, the heat current due to convection is found to be approximately proportional to 5 over 4 power of the temperature difference between the surface and the main body of fluid. Okay? So, yung radiation naman is um, is the transfer of it of electromagnetic waves such as visible light, infrared, and ultraviolet radiation. So, everyone has feel warm of the sun radiation, no? And intense scent of a charcoal grill. Hindi naman sa'tin sila directly hinahawakan pero nararamdaman natin yung init. So, most of the heat from this very hot bodies reach you not by conducting or convection in the intervening air but by radiation. Okay, dumadating daw yung heat na yon hindi dahil sa conduction and convection. Ito ay for the radiation. This heat transfer would occur even if there were nothing but vacuum between you and the source of heat. So, everybody, even ordinary temperature emits energy in the form of electromagnetic radiation. So, ito yung nakikita yung mga thermal camera natin, katulad ng nasa image ngayon. So, around 20 degrees Celsius, nearly all energies is carried by infrared waves with wavelength longer than those of visible light. So, as the temperature rises, the wavelengths shift to shorter values. So, mangyayari at 800 degrees Celsius, a body emits enough to a visible radiation to appear red hot. Eh kapag nag 800 degrees na daw yung body, nag-i-emit na siya ng visible radiation na kung makikita natin doon sa mga iniinit nating bakal. Although, even at these temperatures, most of the energy is carried by infrared wave. So, at 3000 degrees Celsius daw, the temperature of an incandescent lamp filament, the radiation contains enough visible light that the body appears white hot. Yon naman yung para sa ating incandescent lamp. So, the rate of energy radiation from a surface is proportional to the surface area A and to the fourth power of the absolute Kelvin temperature T. The rate also depends on the nature of the surface. This dependence is described by a quantity called emissivity. Okay? Dito papasok yung tinatawag na emissivity. Ito, na tinatawag nating E. Ayan. A dimensionless number between 0 and 1. So, yung E daw is from 0 to 1. Dimensionless daw yan. So, yung E daw represent the ratio of the rate of radiation from a particular surface to to the rate of radiation from an equal area of an ideal radiating surface at the same temperature. So emissivity also depends somewhat on the temperature. Thus the heat H equals to dq over dt due to radiation from surface area A. Emissi- 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 Emissivity E at absolute temperature T can be expressed as H equals to A, or the surface area, multiplied by E, tapos alpha. Alpha ba to? Delta. Di ko na naman familiar to. Tapos T raised to 4. So ito yung formula ng ating radiation. So ito daw is the fundamental physical constant called the Stefan Boltzmann constant, no, na naka-honor sa late sa naka-discover sa kanya si Stephen Boltzmann noong 19th century. So ito is equal to 5.67040040, no, times 10 raised to 8. So ang unit nito is watts over square meter multiplied by K4. Okay. So meron tayo ditong example, no? So parang yung kanina lang to, ha. Okay, dito tayo sa radiation and absorption. So while a body at absolute temperature T is radiating, its surrounding at temperature Ts are also radiating. So in the body absorbs some of the radiation if it is in thermal equilibrium with its surrounding T equals to Ts. And the rate of radiation absorption must be equal. For this to be true, the rate of absorption must be given by H equals to AE delta T4. No? Then the net rate of radiation of body, temperature, um, then the net rate of radiation from the body at temperature T with the surrounding at temperature Ts is itong formula na to. Okay? Yan. So, meron tayo ditong example, no? What is the total rate of radiation of energy from a human body with a surface area of 1.2 square meter and surface temperature of 30 degrees Celsius or equals to 0.3 Kelvin? If the surrounding are at a temperature of 20 degrees Celsius, what is the net rate of the radiative heat loss from the body? So the emissivity of a body is very close to unity, uh, irrespective of a skin pigmentation. So, paano to? Oops, last na pala to, no? So, we must consider both radiation that emits and the radiation that's absorbed from its surrounding. So, magagamit natin dito yung equation na H is equal to A, E, to T4. Okay? Gagamit natin yan. And magagamit din natin yung H net is equal to AE T4 minus AE S para surrounding, no? 4. Or equal to AE, ito yung constant natin, T4 minus TS4. Ayan. So, sabi niya dito, E equals to almost unity. Ibig sabihin, yung E natin dito is almost unity 1. So, gamit itong formulang to, pwede nating makuha yung rate, body radiates at a rate. So, galing sa formulang to, H is equal to A E, the constant T raised to 4. So, dito is magiging 1.2 meter, square meter. Yung E natin is, unity is 1. Yung constant natin is 5.67 times 10 raised to negative 8. Ito is watts square meter, K4. Okay? Tapos yung T natin is 330. Okay? Okay? So, dito, using our calculator, lalabas dapat yung answer dyan. 1.2 multiply by 5.6 times 10 raised to negative 8, tapos multiply by 330 raised to 4. Teka, mali yung lumabas sa akin. Ulitin mo na. 1.2, 5.67 times 10 raised to negative 8 multiply by 303 is to 4. Ayun. So, lalabas is 574 watts. Okay? So, this loss is partially offset by observation of radiation. So, depende ito sa temperature of the surrounding. So, gagamitin natin yung formulang ito para makuha yung net rate. No? So, H net equals to A, E, yung constant natin, tapos T4 minus yung surrounding. Okay? So, paano lalabas yan? Siyempre, 1.2 square meter multiply by E, 1. Tapos, yung constant natin is 5.67 times 10 raised to 8. So, watts square meter, K4. Yung T4 natin is yung kanina, no? Yung 303K. Naka-fourth power minus ah, 293. Surrounding natin. Okay. So, gamitan natin ang calculator. 1.2 tapos 5.67 times 10 is to negative 8. Tapos 303 raised to 4 minus 293 raised to 4. Ayan, so lalabas is 72 watts. So ito na ngayon yung answer natin. Ito. Okay? So, yes, yung last na yan na problem natin. Ayan. So, dagdagan ko lang yung application ng radiation, no? So, napakaraming application ng ating radiation. So, unang-una, pinaka-common is yung magpapainit tayo kung nasa malamig tayong lugar. May gumagamit sila ng furnace. So, yung nakikita natin sa mga moving may Princess Sarah, yung may chimenea. So, ginagamit nila yun para magpainit. So, gumagamit yun ng radiation. So, isa pang magandang example nito is yung mga premature baby na nasa incubator. So, ginagamitan nila ng radiation para uminit yung baby. Okay? So, a body that is good absorber must be also a good emitter. So, an ideal radiator with an emissivity of unity is also an ideal absorber. So, absorbing all the radiation that strike it, such an ideal surface is called the ideal black body or simply a black body. So, conversely, an ideal reflector which absorb no radiation at all is also very ineffective radiator. So, ito yung reason kung bakit meron tayong silver coating doon sa ating thermo, no? Ito ay naimbento ni Sir James Dewar noong 1842. Ni Sir James Dewar na nabuhay ng 1842 hanggang 1923. So, a vacuum bottle or tinatawag nating thermo has a double glass wall. So, the air is pumped out of the space between the walls. So, this eliminates nearly all heat transfer by conducting in convection. So, the silver coating on the walls reflect most of the radiation from the contents back to its container. So, ito yung reason kung bakit napapatagal ng thermo yung yung mainit na tubig sa loob. So, thus a vacuum bottle can get coffee or hot soup in the several hours, no? So, sa Dewar Plus used to store very cold liquefied gases. So, same lang yung principle na ginagamit. Siguro hanggang dito na muna ako, no? So, sabi ko nga, ilista nyo lang lahat ng hindi nyo naintindihan dito sa topic na to. And i-discuss natin siya ngayon doon sa synchronous meeting natin. Okay guys, so medyo umiiyak na naman yung anak ko. Hanggang dito na muna siguro ako and abangan nyo yung next upload ko. Okay, thank you.